Envision an organization. This organization wants to ship their products in less than 5 days after the order date. Management expects from operation to achieve this goal in 95% of all orders. This is a quality standard. However, in reality, shipment times will vary. Shipment times could vary between 3 and 9 days. And praxis might show that only 60% of all shipments comply with this quality standard. In such a case, there is a quality problem. The value of one or more quality variables cannot be successfully controlled within specified limits. An intervention might be considered. But how do managers know for the given quality problem what intervention will work best? Of course, the Lean Six Sigma methodology offers support for answering this question. Under the right circumstance, Lean Six Sigma can generate valuable evidence which is helpful to decide which intervention is preferable. But it's not always that simple. There are many reasons why Lean Six Sigma results might not be held. For example, experiments to validate results require interventions to exclude the influence of variables on the outcome. However, we know that interventions might introduce effects, and these effects might influence the quality variable. This is known as the Hawthorne effect.
Between 1924 and 1932, the Hawthorne Works commissioned a study to see if their workers could become more productive. One intervention seemed to be better than the other. However, the productivity level dropped as soon as the study stopped. In 1958, Henry Landsberger re-examined the results of this study. He concluded that the measured effect probably was caused by the extra attention that was given to the workers. In other words, the intervention introduced a new variable which led to spurious correlation.
While the Lean Six Sigma approach advocates to verify and demonstrate results by experimentation, the Hawthorne effect meant for those who are conducting experiments became extremely reluctant to intervene. So if it's difficult to create the right circumstances for experimentation in Lean Six Sigma, how does a manager make an informed choice what intervention is needed, without a feeling he or she puts business continuity, their job and reputation on the line? For instance, the options in business process redesign.
Some redesigns are safe for business continuity, but perhaps less effective. Other redesigns can be risky, but more effective.
I believe experimentation in Lean Six Sigma is only part of the story. Causal mechanisms are vital too. However, they are currently neglected.
It was known at the time of the Hawthorne experiment that if a group of individuals is isolated from other groups, the normal human instinct to feel chosen will skew the results. In these days, it was common to neglect social mechanisms in scientific management. Nowadays, there is little doubt that many fields, from psychology through to business management, must appreciate that social science subjects can, and do, change behavior in organizations too.
While experimentation in Lean Six Sigma looks at what happens when an intervention takes place, causal mechanisms describe why it happens. I believe the Lean Six Sigma methodology should include the idea to integrate different types of evidence. Not just experiments, but data, background knowledge of employees, comparable case studies, and experts' testimonies to build a wide-ranging picture of how and why an intervention works the way it does. It is only by bringing together different types of evidence you can truly understand if one intervention is better than another, and in fact if an intervention is suitable for use at all. In my research, I exploited the idea of applying triangulation in Lean Six Sigma projects. Triangulation is in science a research strategy in which different kinds of evidences are combined to identify and confirm a causal hypothesis. What can be learned from its introduction in evidence-based medicine?
A new generation of researchers apply triangulation in evidence-based medicine. These researchers aim to identify a causal mechanism to learn what happens when an intervention takes place and why it happens. The choice for triangulation is supported with arguments such as combining kinds of evidence leads to greater validity, and the gaps in the data that is collected with experimentation can be filled with additional evidence.
Two important conditions contribute to the successful implementation of triangulation in evidence-based medicine. First, the strict procedures for conducting random controlled trials. Second, the availability of theories, laws and formal modeling languages to understand causality in chemistry. If we return to the Lean Six Sigma, we miss the latter condition. The absence of theories, laws and modeling language to understand causality in social systems hinders the introduction of triangulation in Lean Six Sigma. I believe enterprise engineering can help. Why?
Researchers in enterprise engineering study organizations as a social system and develop organizational theories and modeling languages on two distinct abstraction levels. The lowest abstraction level, the implementation level, is denoted as enterprise architecture. Archimate is, for example, a modeling language on the implementation level. By applying Archimate, one can model an organization from a functional perspective to understand how it is organized. The highest abstraction level, the ontological level, is denoted as enterprise ontology. DEMO is, for example, a modeling language on ontological level. With DEMO, one can model an organization from a constructional perspective to understand how it operates.
To test the feasibility of triangulation in Lean Six Sigma, we tested both abstraction levels in two real-life Lean Six Sigma projects. Practically, we augment in each project the established Archimate and demo model with the variables under investigation. Subsequently, we replay the data on the augmented model to learn if the augmented model supports us in identifying a responsible causal mechanism for the quality problem. From both case studies, we learned that triangulation is a feasible idea. However, we learned also that enterprise architecture is not an ideal abstraction level to identify a causal mechanism. Compared to enterprise ontology, enterprise architecture lacks causality. Enterprise ontology prescribes to process information about the organization through the psi theory and its axioma. This is a causal theory based on the idea of causality in social interactions. Through applying the psi theory in combination with the statistical results from Lean Six Sigma, we can causally understand what happened and why it happened. What does it mean for Lean Six Sigma? We advise to apply triangulation, the convergence of two different kinds of evidence, if there is a strong motivation. For example, if an accurate understanding of the causal mechanism that maintain the quality problem is needed to evaluate if one intervention is better than another. If triangulation is needed, focus in the way of working to establish reliable statistical results, or in technical terms, reliable evidence of difference making. Furthermore, focus in the way of modeling on obtaining a reliable causal model for the organization under investigation, or in technical terms, reliable evidence of production. And finally, center causal mechanisms in the way of thinking. Converge both evidences for the purpose to demonstrate, to establish an accurate understanding of the causal mechanism, so you can evaluate if one intervention is better than another. And in fact, if a proposed intervention is suitable for use at all.